All right, so this is going to be called the problem of what not to do. We've done all the wrong things on this problem. First, we forget to plug in both numbers. Now we reverse the limits. All right, so 0. So now we've done all the mistakes for you. You'll know.
Do it one more time.
You'll know what to do. All right, so notice how the limits go. It was 0 on the top and -5 on the bottom. If we want it to be, so it was supposed to have been 4 on the bottom, or excuse me, on the top, and 9 on the bottom, because the smaller number gave us the larger result. Now, all is not lost, because what if we want to switch these? So instead of going from 9 to 4, so that we go from high to low, how can we switch those? Yeah, we just switch the sign to positive. So now this becomes positive. There's nothing to distribute anymore. So now this term here is not going to be this is going to stay negative. This is going to be positive. So this one is negative. This one would be positive. This would be negative. This would be positive. That makes this one negative, this one positive. This would still be this would be positive. This would be negative. So it's just going to be the signs. So negative, positive, negative, positive, negative. Wait. Negative, positive, positive, negative. There you go.
He's probably so confused right now. Negative, positive, negative. He's like, what the?
All right, does everyone see what, let's go through this. So everyone see what we did? So now it reminds me of something very, very important to tell you, is that when you plug in and change the limits here, make sure you pay attention to who gave you what. The smaller number gave us the larger answer, so it does have to be 9 to 4, not 4 to 9. So it just makes sense that it should be 4 to 9, small to high, but because it was the 0, they gave us the 4 is on top. The -5 gave us the 9 is on the bottom. But I don't really like those limits, so we could switch them and get rid of the negative altogether.
Could I not just plug in 4 and then subtract it from 9 and then have the negative in front to make it positive anyways?
What I would do is you'd plug it in like this and just get rid of the negative sign, and then switch them back the other way.
And then, can I just suggest that we just cut this one out and go to the next one?
Let's go to the next one.
And just cut it out.
No, he'll watch it.
He won't.
Whether he watches it or he does, he has to know how to do the problem. So.
I was just gonna say,
all right, so let's go to the next one. All right, so we're gonna evaluate this one, 2 cosine 3x on pi 6, 0 using method 1. So that's going to be, we're going to substitute back. All right, so we need to find our u. What's our u?
Cosine 3x. Was it right?
No.
Got it.
So I may as well erase it.
Is it cosine x?
No.
Is it just 3x?
Yes.
Why?
Because that's the chain part. Cosine's got raised to a power. So the only chain part of this is the 3x part. So now we have du dx equals 3. We don't have a 3. We have to multiply both sides by dx. So du is 3 dx, and we'll divide by 3. So 1/3 du is equal to dx. So the 1/3 du will take, we have a 2 there. The 2 can stay, right? You can stay. So this will stay. Because he's there, right? Because he's there already. The 2. No, we could pull it. We could pull them out of the thing. Yeah. But we are only rewriting. We're only replacing this part here. So this is the u, right? And then the 1/3 du is the dx. The 2 can stay, and the cosine can stay, right? Because the cosine is not part of the chain. 2 is just a coefficient. I could have factored him out to begin with, right? So that's no problem. There's no point in doing anything else with that 2. So we'll rewrite the 2, and the 1/3 du here is 2/3, and we can just pull that out. All right, so 2/3, the integral of cosine u du. Right, and we're not going to put the limits in because we have to switch back. All right, so now when we integrate cosine u, what's that?
negative sine u.
Right. So we're going to have 2/3. Oop. Funky 3 there.
And it's when you take out the 1/3 from 1/3.
It's the 2 and the 1/3.
Take out the 1/3 and you have 2/3.
So we're going to have negative 2/3.
Wait, why negative?
Because
Oh, negative cosine. Okay, negative sine. That's why. Okay, I'm just checking. I don't want to. Because yeah.
sine u, and now we need to substitute back. So the u is 3x. So we have negative 2/3 sine 3x. And we're evaluating that from 0 to pi 6.
Are you sure?
So we'll plug that
Pi 6
in,
to
yes.
0.
What's that?
It's okay, never mind. You went low to high.
That's where you usually go. All right, so 2/3 sine times 3 times 0. And then I'm going to just distribute the negative 2/3 at the end.
No, wait. Don't you have to plug that into something else? Don't you have to like change them?
No.
Like we did on the last problem?
No, because we were doing the other method. We substitute back. So this is method 1, so we're substituting back. All right, so minus sine 3 pi 6.
Is it the other way around?
No, low to high. Oh, excuse me, high to low. Oh my gosh. High to low.
This is a rough class.
I don't know. I have no explanation for today. High to low.
Everybody just takes.
I've been teaching 3 straight periods, so.
Yes.
We're fine with having this as a nap time.
All right, let's go.
Bring back nap.
All right, so this would be sine pi halves minus sine 0. All right, pi halves is right here. Sine is 1. So this is going to be negative 2/3 times 1 minus sine of 0 right here is 0.
No, you forgot to do. Oh wait.
I didn't forget anything on this time.
Are you sure?
Oh, yes, I'm sure. And the answer is negative 2/3.
No, wait, no,
Don't
no,
listen to
that's not
Cole.
Wait, no, that is right.
It is right.
Yeah, just checking.
Good job, Cole.
Thanks.
Right, but don't call out that it's wrong.
I didn't say it was wrong. I just said wait. That doesn't mean anything's wrong. It just means I'm either confused or I want to make sure I'm following your work correctly.
Okay, that's fine. All right, so negative 2/3 is our area. So obviously we're under the x-axis. I will make no errors on the next problem.
I have zero faith in you.
Wow.
Well, how about that?
Not because you're bad at math, but because just
How this is.
It's
your
okay,
track
she lost
right
faith
now
in
is
you.
not looking very good.
It's okay, Cole. She lost faith in you years ago.
Yeah.
And I can lose back.
I'm changing the page.
That'll show
Oops, where's my, I have no cursor. There we go.
Believe in them anymore.
Yeah.
All right, so this is going to be method 2, same problem. All right, so we're,
Not always. What?
She can fail you. Like
She can.
that.
But she can't fail me for saying that, like, if she doesn't, like, think
I'm
she's
just going to
smart.
continue on. I didn't say anything. I'm just continuing on. All right, so 2 cosine 3x dx. The u is the same problem as 3x. Our du dx is going to be 3. We don't have the we need to multiply both sides by dx, so du is 3 dx. And we'll divide both sides by 1/3 because there's no 3 to replace. So 1/3 du equals dx. All of that is the same. The only thing that we have to change is those the limits. So now if, and I'm going to go low to high, right? So we're going to put this, whatever number this is, this goes at the bottom. So if x is 0, right, then 3 times 0 is 0. So that didn't change. If x is pi 6, then 3 times pi 6 is going to give us pi halves. So this time we're changing the limits. I plugged in 0, I got 0. I plugged in pi 6, I got pi halves. And so now we'll integrate. All right. Oh, excuse me. I forgot to, I didn't change the thing here. So this was the original problem. I didn't rewrite the problem again. with our substitution. So our substituted problem is we're gonna take that 2 and the 1/3, and that's going to come out, so we have 2/3. We're evaluating it from 0 to pi halves, and now it's cosine u du. Right, because the 3x here was the u, the 2 and the cosine stayed, the dx is the 1/3 du. Everyone good? All right, so now we evaluate, we're still going to get the same thing. All right, it's going to have negative 2/3. It's going to be sine u, but we're not going to substitute back. We're going to evaluate that from 0 to pi halves. So we have negative 2/3 sine pi halves minus, I'll distribute at the end, but it's really not going to make a difference, sine 0. All right, and so that's going to give us negative 2/3 times 1 minus 0, which is negative 2/3. Right, so same answer. It's usually easier not to have to do the substitution back again, depending on the problem. I just usually talk through, I usually when I'm doing this, I usually actually put the numbers on the integral itself as soon as I plug it in. I don't usually make that error. I don't think I've ever made that error before, where I switched them. All right, so this one is just going to be method number 2. All right, so now what's our u here? Yes. What's d?
We did it with method 1 before.
Yeah.
Did we do method 1 or method 2?
We didn't do
Method 1.
Method
Is this the
1?
one that we messed up and did method 2 on accident first?
No, this is the one messed up one. Yeah.
Okay, so we're going to do method 2. Yeah. All right, so our derivative du dx is going to be 2x. We don't have the 2 there, so we'll divide by 2. So du is 2x dx, and then we divide both sides by 2. So 1/2 du will replace x dx. So this here is the 1/2 du. This part here is the u. The only thing that's going to stay is the 3. If we're using method 2, we'll change the limits. So if where's my if? X equals 1, then, and actually I'm going to do this right away. All right, so this is going to be, we have the 1/2 coming out, and we have u cubed du. All right, so let's just rewrite that right away. Everyone okay with that?
Mm-hmm.
Okay, so if x is 1, then we have 1 squared plus 2 is going to be 3. So I plugged in the bottom number first, the 3 goes there. If x equals 2, then 2 squared plus 2 is going to be 6. So, and I plugged in the 6. Or I plugged in the 2 and I got 6, right? So it kind of, if you write it in as soon as you do it, it kind of helps out. All right, so now we'll just evaluate, and we're not substituting back. So what's the integral going to be for u cubed?
U to the 4th over 4.
Yeah. And we're going to evaluate that from 3 to 6, and let's simplify that. So we have u to the 4th divided by 8 from 6 to 3. So that's going to be 6 to the 4th divided by 8 minus 3 to the 4th divided by 8. Yeah, I remember doing this one. So this would be 6 to the 4th. 6 cubed is 260. Was it 1296? 1296 eighths minus 81 eighths is going to give us 1215 eighths, and that's not going to reduce because that's not an even number. So see, we got the same answer. This was one I think that I kind of like changing it because I didn't really want to substitute back into the thing. I think it was a little bit easier to change those limits. Sometimes it makes no difference. Oh, sorry.
It's fine, I got it.
But Tristan did it.
Oh, okay.
Not everything's about you, Brian.
What page are we on in the notes?
The third page.
right now.
So we've got 2 pages left.
And some of them are, like, there's not a lot, it just took up a lot of space.
Right. So we've got 1, 4, 5, 6, 7. We've got 8 problems left.
All right, so how about what's U going to be?
T cubed plus 1.
Yeah.
To the 19th power.
And since, let's practice method 2.
Multiply it out first.
Yeah.
So we'll use method 2. We're not going to do everything with 2 methods. We'll use method 2 because that's the one that is a little bit new, right? I don't care which one you use, but Bob, we should practice a new one. All right, so t cubed plus 1, and so du dt is going to give us 3t squared. And notice we don't have a 3t squared, we have a 6t squared. That's okay. So du is equal to 3t squared dt, but we want 2 du. So 2 du will give us 6t squared dt. You can multiply and divide by a constant. Right? That's not a problem. We can differ by a constant. So it was really a 2 du we needed. So 2 du will take over for this one. This is u, and to the 19th power stays. And let's get our new limits. So, and now we're going to be watching this. Which one we plug in? Let's start bottom. We'll always do bottom, and then we won't mess up. So if t equals -1, then -1 cubed plus 1 is going to give us 0. If t equals, and that's our bottom one. So I'll rewrite this right now. So we have, the 2 can come out. So we have 2u to the 19th power du, and then we plugged in -1, we got 0. If t equals 0,
You get 1.
then, yeah, 0 cubed plus 1 is 1. So now we have 0 and 1 as our limits. Pretty easy numbers to work with. All right, so we'll integrate. So this will be u to the 20th divided by 20, and then we're going to evaluate that from 0 to 1. And this is pretty easy. So this is going to be 1 to the 20th power divided by 20 minus 0 to the 20th power divided by 20, which is 1/20.
You forgot the times 2.
Oh, times 2. Don't forget him. Oops. 2 times 1/20th. 1/20th. I'm saying one thing, writing another, but I'm thinking of the answer because it's 1/10. And I forgot to write it over here. That's just how I dropped it. So don't forget to write those in. Maybe a good idea is underlining them. Make them stand out, so they don't get lost in the integral sign or in the limits. Okay. So I think it was nicer to just kind of get the numbers and then just be able to plug those in because they were really easy to work with. Any questions on this one? So I'm just going to do that one time. And then we have this one. All right, so
Our u is x squared minus 6x plus 9.
and
Or is it x minus 3?
what's that?
Is our u x minus 3 or x squared minus 6x?
Well, yeah, we could rewrite that as,
X minus 3 squared.
yeah. So let's try that, all right? Because it's not looking really good to keep it the way it is. All right, so let's rewrite this as x minus 3 squared. Because now I think we can do something with this.
Yeah, 'cause now
Whereas
our u is-
before
now
we're
our
kind
u
of
is
stuck.
x minus 3.
Yeah.
Have the chain rule.
Exactly. So before we can't do a chain rule because we don't have a 2x minus 6, which is what we would be left with. So now we can see our u can be x minus 3. So our du dx is going to be 1. So du is dx. So now the,
du over.
yeah, so we're going to just have,
This is
we're going to have du, and we're going to have u to the over u squared. Now we need to rewrite that. And we need our new limits. So let's get our new limits, and then we'll rewrite that, and we'll just integrate real quick. All right, so if x is 1, then 1 minus 3 is negative 2. So that's the bottom one. Actually, I can't put it there because that was the 1 and 2. Now this is now the negative 2 once we switch to the u's. If x equals 2, then 2 minus 3 is negative 1. They're going in order anyway, from low to high. Let's rewrite that as u to the negative 2. So we have, from negative 2 to negative 1, we have u to the negative 2 du. So what's that going to be?
Negative u to the negative 3 over negative 3.
No.
Wait, what do you mean? Negative 2 plus 1 is not negative. Oh wait, u to the negative 1.
Yeah, u to the negative 1 divided by 1 or times 1. And then we're evaluating that from negative 2 to negative 1. I'm going to have to write over here because I'm writing a space. Whoop. Equals. So we're going to, let's leave the negative to the end here. All right, so we'll have, and now I'm just going to write, I'm going to rewrite this, instead of having it as u to the negative 1 as 1 over, right? So this is the same as negative 1 over u, from negative 1 to negative 2 to negative 1. So we have 1 over negative 1 minus 1 over negative 2, right, from high to low. So this is going to be negative, so this is negative 1, and then plus 1/2. So that's going to be a negative half, so that's positive 1/2. Right? And that was very good thinking about the factoring. I was hoping someone would figure that out, because we'd be stuck. We can't do anything the way it was. If that had not been a perfect square, this would be called one of those that we could never evaluate. It's possible that it could sometimes completing the square can make it something that we can work with, and then we'll see problems like that in the next lesson. And I think that's probably going to be the end of our tape.
Bye, Dylan.
You never know; other people could be watching this.
Yeah.
Although